We are going to present Deblurred neuroradiant field with physical priors, which we named as DP-NeRF. Neuroradiant field, which we call NeRF, has laid the explosion of the 3D scene representation from multi-view images. It accurately synthesizes a novel view images based on the trained neural network using the volume rendering technique. However, there are not as much researches on neuroradiant field on some challenging scenarios such as degraded images with noises. Specifically, we treat the neuroradiant field on blurred images, which can be frequently acquired in real-world scenarios. This blurred information leads to the nerve network to model the blurred 3D scene representation due to the lack of accurate information on pixels. To solve this problem, previous work modeled the blurring corner to put the blind deblurring algorithm on nerve system and could make the claim neuroradiant field. However, the kernel is only considered on each pixels independently, which leads to the inconsistent scene representation. To handle this, we impose the physical priors on blurring process and can make more clean and consistent scene representation. Here is our final results compared to our previous work on camera motion blur. Our target blur type is camera motion and focus blur, which we can often observe when we take the pictures. Our work shows more accurate geometric consistency in rendered video. We also shows another results on defocus blur. Now here we describe our proposed method. We are motivated from the physical blurring process in image acquisition. In particular, blurring usually happens when there is some camera movement or specific focus plane on single camera condition. This kind of processes happen simultaneously during camera exposure. To construct the blurring corner with 3D consistency, we model the rigid blurring corner using rigid transformation of given camera pose in each view. This corner mimics the previously mentioned physical process with respect to image acquisition. For camera motion blur, the corner model how camera had been moved during blurring process. The volume rendered on each transformed rays produce the claim pixel colors. The colors are composited to generate the reference blood color with weighted sum using the coarse composition weights, which are also predicted from rigid blurring corner. For the focus blur, our model works as well in more interesting way. After the training, predicted camera motion during blurring process is naturally located at virtual aperture to decide the focus plane of the given image. As same as camera motion blur, rendered each transformed pixel colors are composited to blood color with weighted sum using the coarse composition weights. Actually, we had to consider the relationship between depth and blur to accurately model the blurring corner. We alleviate this issue by introducing the adaptive weight proposal network, which predict color composition weights with additional 3D occupancy information. We use the occupancy features of the samples on the transformed rays as representative features of each ray. Then the feature and camera features are forwarded to motion aggregation module to predict the composition weights, which consists of transformer-like attention networks on motion and ray-wise features. Then finally composited colors are our additional predicted blood colors to compute loss. Here are our comparison results with NeRF and previous work on camera motion blur. This is the results on the focus blur. Here are more additional results. Thank you for watching our video. Please see our paper, supplementary, project page, and source code to get more detail.